NASA gears up for Artemis II with a countdown test with the crew. The US Space Force opens up to leasing 2 launch sites for large rockets. Tory Bruno leaves ULA and joins Blue Origin, and another reusable rocket debuted from China with similar results to the previous one. As always, we've got all that and more coming up this week in Spaceflight. NASA is inching closer to their first human spaceflight around the moon since 1972, the Artemis II mission. This mission will be the first launch of SLS and Orion with humans on board, and several new systems will be put to the test throughout the mission. For that reason, the crew has been training for months in order to be ready for every eventuality. Over the last year, NASA has been assembling the Space Launch System rocket that will send Orion and its crew into orbit. Orion also had its own series of assembly steps and checkouts before it met with the rocket a few months ago. With both mated together, NASA carried out a countdown demonstration test with the crew a couple of weeks ago. Artemis II will carry Commander Reed Weissman, pilot Victor Glover, and mission specialist Christina Cook, all of those from NASA, and Jeremy Hansen from the Canadian Space Agency. During the weekend of December 19th, the Artemis II crew carried out several training activities along with the ground crews and members of the launch control team. Friday, December 19th itself saw them conduct emergency rescue training at the Kennedy Space Center, making sure to rehearse these operations in the unlikely event that something were to go wrong during countdown operations. Then, on Saturday, December 20th, came the countdown demonstration test, a dress rehearsal of the countdown operations while the rocket sat inside the vehicle assembly building. The crew got dressed with their launch and entry suits, and went out to the rocket and boarded their capsule named Integrity for a full countdown rehearsal. This test allowed the crew, launch teams, and closeout crew to practice all the different events and procedures that will happen on the actual day of launch. It's not the first time this is practiced, but it was the very first time that it was done with the actual flight hardware rather than on a simulator. Since the test occurred, the crew has flown back to Houston and continued training on the simulators before the holiday break. But soon, they'll be busy again because, if all goes well, SLS should be rolling out to the pad in the next couple of weeks. Many of the access platforms to SLS have already been retracted, and work should soon be underway to finalize the installation and testing of the rocket's flight termination system. Once out on the pad, teams will perform another set of rehearsals. One of them will be, again, with the crew, but without loading propellant, and a final one with no crew, but loading propellants on board. If those tests go well, we could see Artemis II taking off during the first week of February, so fingers crossed everything goes well for everyone involved. The US Space Force ended the year by awarding over $3.5 billion in contracts for the tracking layer Tranche 3 of its proliferated warfighter space architecture. Okay, that's a bit of a word salad, so let's unpack that before we have a look at who the lucky winners are. And one of them got their biggest contract yet, but again, more in a bit. The Space Force's Space Development Agency, or SDA, is working on a missile warning system made from a network of satellites that all interconnect in space. The system is called the Proliferated Warfighter Space Architecture, previously also known as the National Defense Space Architecture, and as you can probably expect, once operational, it will be an important asset for the US to defend itself from missile threats. Now, this system consists of several parts with different responsibilities, or layers as SDA calls them. Some of the layers consist of satellites, some are for ground systems, and some of them are much further developed at this stage than others. For example, one of these layers is the transport layer, which forms the system's communication backbone. Once completed, it might consist of 300 to 500 satellites orbiting between 750 to 1200 kilometers above our planet. At any given time, 99% of Earth's surface will have at least one of these satellites in view. And they're not just for communicating up and down, they'll also use optical links for communication between the satellites, which is the same approach SpaceX uses for Starlink. Another layer in this system is the tracking layer, which, as the name suggests, is designed to spot and track missiles launched all around the world. This is also the layer we're talking about today, as those contracts were awarded for this layer. There's one more word in need of explanation. The contract was awarded for Tranche 3. So all these layers are developed in stages called tranches, starting with Tranche 0, which was really just the demonstration phase. This one consisted of 28 transport layer satellites and 8 tracking layer satellites. The Tranche 0 satellites, or space vehicles, to use the Space Force terminology, were launched by SpaceX in 2023 and demonstrated the concept's feasibility, not just on a technical front, but mainly in terms of cost and scalability. Tranche 1 is also known as the Initial Warfighting Capability Tranche, which I assume is pretty self-explanatory. The first satellites for this tranche made it into space in September and October, and more are set to launch this year. Tranche 2 and 3 each expand the constellation. So this week, the SDA awarded the contracts for Tracking Layer Tranche 3, and you'll know now that means it's to expand the missile tracking capabilities of the Space Force's missile warning system. But how much missile tracking does $3.5 billion buy? Well, there are 4 contracts, each for 18 space vehicles, or 72 total, which will ultimately make their way to low Earth orbit in 8 orbital planes. And as you might expect, most of the contractors are familiar names in the defense industry, and all of them have received previous SDA contracts. The largest chunk, $1.1 billion, went to Lockheed Martin, which promptly assigned the task of building the 18 satellites to its subsidiary Terran Orbital, which it acquired in August 2024. L3Harris received $843 million, and the smallest contract at $746 million went to Northrop Grumman. The final contract went to a company that gets more airtime on This Week in Spaceflight compared to the other 3, Rocket Lab. Since they also provided the most information on their plans, we're not going to break the pattern here. The company got awarded a contract of over $805 million, which makes this extra special as it's the company's biggest contract ever. Like the others, Rocket Lab will build 18 satellites, and the company plans to do that using its Lightning satellite bus. Rocket Lab originally developed the platform for Globalstar, but it also used Lightning for the 18 satellites of its Transport Layer Tranche 2 contract, worth over $500 million. The satellites will be outfitted with Rocket Lab's own Phoenix infrared sensor, which will detect missiles. In addition, the company plans to install its Starlight sensors on the space vehicles, which, according to Rocket Lab, are, quote, designed to safeguard the constellation against directed energy threats. Apparently, this is an important feature as some of the other Tranche 3 contractors will install these very same sensors on their satellites. Although Rocket Lab only received the second smallest contract out of the 4, by selling these and other subsystems to the other contractors, Rocket Lab hopes to get over $1 billion out of this deal. With 19 launches currently scheduled for Tranche 1 and 2, and with these 72 additional satellites now underway, this certainly won't be the last we hear about the proliferated warfighter space architecture. And I'm happy to let Alicia keep saying that mouthful. Let's just hope it never needs to be used for its design purpose. The US military wants big and cheap rockets to launch the many missions and satellites they plan to put into orbit. But for those big rockets to launch, there's got to be a place for them to launch from. So, in the last 2 weeks, the US Space Force has issued 2 separate requests for information to see if there are companies interested in launch pads for big rockets to launch from each of the US coasts. The first one of these was released on December 19th and involves Florida Space Coast. The request for information proposes Space Launch Complex 46 as a launch pad that would be used for launches of super heavy lift rockets. Slick 46 is right at the tip of Cape Canaveral, just south of Blue Origin's Launch Complex 36, and has been in use since the late 1980s. On the orbital rocket side of things, the site supported 2 launches of Lockheed Martin's Athena rocket in the 1990s, a Minotaur launch in 2017, and 2 launches of Astra's Rocket 3.3 in 2022, both of which ended in failure. Launches from the site actually tend to be suborbital launches, such as the Orion Ascent Abort test, which took place there in 2018. The rest of the suborbital launches, though, have been for the US military. Slick 46 initially supported launches of Trident missiles for the US Navy, and in recent times has been used to launch demonstrations of long-range hypersonic weapons over the Atlantic. The request for information by the Space Force states that, because of its important role supporting US Navy operations, Slick 46 won't be up for lease until this role can be replicated elsewhere within the Space Coast. This replication work is also something that they won't be involved with and would have to be up to the Navy to carry out on their own. Whatever needs to be removed after the relocation will be up to the launch company to deal with. What's probably interesting from this is the request states that it wants to increase launch diversity from the Eastern Range. It states that, quote, with more requests than available launch pads, Space Launch Delta 45 seeks to bring new launch vehicles to the Eastern Range rather than providing second pads for any existing launch vehicle currently operating on the Eastern Range. Therefore, companies would have to add in their response to this request, whether they have another pad already on the Eastern Range for a rocket with those capabilities or not. This would make it a bit harder for SpaceX, for example, to try and get this launch pad for Starship, since the company is already working on building 2 launch pads within Space Launch Complex 37 and a third being finished at Launch Complex 39A. If anything, this site might be more suitable for Blue Origin to eventually have more launch pads for New Glenn, especially now that we know they're working on their larger 9x4 variant. Who knows? Perhaps there might even be larger versions of the rocket down the line that might also need a separate pad. Given the Space Force's definition of super heavy lift as being able to launch more than 50,000 kilograms to orbit, there really aren't any other companies out there with rocket designs that can fit the bill as of now. Of course, this is just a request for information, or, in other words, a formal way for the Space Force to ask if there's any interest in using Slick 46 for this purpose. It doesn't guarantee that it'll actually be turned into a launch pad for big rockets, but it does show their willingness to offer more sites for such vehicles. Just 11 days after the first request for information, the Space Force released another one to develop a brand new launch site at Vandenberg, which would be known as Space Launch Complex 14. This new launch site would be located on the extreme southeast end of the base, near the dock that SpaceX uses to bring their boosters and fairings from Long Beach, and that ULA has also used to bring Atlas and Delta hardware in the past. In this case, the launch pad would be not just for super heavy lift launchers, but also regular heavy lift launchers. Per the definition from Space Force, this essentially means any rocket that can launch 20,000 kilograms to orbit or more. In that case, there would be a few more potential candidates that fit the bill here, including Relativity's Terran R, which is aiming for a performance of up to 33,000 kilograms to orbit. It would also be a nice location for Blue Origin's New Glenn rocket, but the company has allegedly shown interest in Vandenberg's Space Launch Complex 9, located further north. But who knows, it might also allow Blue to launch even more often from the West Coast if they had 2 launch pads at hand. SpaceX could also try and get this for Starship, since they've not proposed any West Coast launch sites for it yet. But they also could just modify Space Launch Complex 6 in the future for that role. Just like with Slick 46, this is just a request for information, so Slick 14 may or may not be eventually developed at Vandenberg at all. But if there's enough interest, we could see this going through. While the military is interested in opening more launch pads for large rockets so they can support their programs, these can also support commercial interests while no national security launch is underway. While you might think Vandenberg is not that useful since you can only do high orbital inclination launches and polar flights, those may become more common if companies start deciding to launch AI data centers into orbit. These would be best suited in sun-synchronous orbits, which are a type of polar orbit and, therefore, easier to reach from Vandenberg than from Florida. It's been a rather hot topic in the last few weeks of 2025, so this move by the Space Force to potentially open up another launch site at Vandenberg may have some big consequences many years from now. But what do you think? Will we see this going through? Maybe more launch pads for Starship in New Glenn? Maybe someone else will snag it for themselves. Let us know what you think in the comments down below. Now we'll take a look at some other stories across space, starting with space industry legend Tory Bruno, who recently stepped down as CEO of United Launch Alliance after leading the company for nearly 12 years. Replacing him is John Elbon, who is now interim CEO, and Mark Peller, who will take over as ULA's chief operating officer. Under Tory's leadership, ULA developed its Vulcan rocket to replace its legacy Atlas and Delta rocket families. With Vulcan, ULA has even taken some timid steps towards reusability. DWise did a video detailing Tory's career up until this point. But this isn't where his story ends, as a few days after his resignation, Blue Origin welcomed him on the team. Tory is a rocket guy through and through, and some have been suspecting that he might have been held back by ULA's owners, and, reading between the lines of some of his tweets, it seems like he did what he could to steer ULA in the right direction and is now jumping ship to a place where he could follow his passion. Specifically, Tory will now be at the helm of Blue's new National Security Group, which he said will, quote, bring important, innovative, and urgently needed capabilities to our nation. We'll have to see what Blue plans to do with this new division, but they definitely picked a highly qualified guy to lead it. The Russian space agency Roscosmos has assembled a brand new rocket at Baikonur, the Soyuz 5. This rocket was supposed to launch around Christmas, and while that obviously didn't happen, Roscosmos did manage to assemble the rocket set to fly on that first mission. Despite the Soyuz name, Soyuz 5 shares little to no heritage with the legendary Soyuz family. The rocket's first stage, a single booster, features one RD-171MV, which feeds on liquid oxygen and kerosene. Although the engine has 4 combustion chambers and nozzles, it's still considered a single engine, which makes it one of the most powerful rocket engines in the world. As a result, Soyuz 5 nears Falcon 9 in terms of performance and offers more than double the payload mass capability of the Soyuz 2, which currently flies crew to the ISS, or at least it will once their launch pad is fixed. One of the rocket's most striking features is its hot staging interstage. On other rockets, like Soyuz 2 and SpaceX's Super Heavy V3, this is essentially a bunch of struts, but Soyuz 5 sports a metal grid instead, which I think looks very cool. But cool looks don't make up for the rocket's seeming lack of customers. Soyuz 5 was designed to replace the Ukrainian-built Zenit rocket, which, for obvious reasons, is no longer available to Russia. It was also meant to be a cheap option for international customers, but that market has all but dried up since the war in Ukraine, and the same geopolitical situation is to blame for Russia's space industry grinding to a halt as well. Roscosmos announced a delay to the rocket's first flight to allow for additional testing and checkouts of the rocket and its ground systems. They didn't announce a new launch date, but it most likely won't be before March. We can only guess what the rocket's future holds beyond then, though. This is your weekly space traffic report provided by NASASpaceflight. It's been 2 weeks since our last traffic report, so there is quite a lot to report on, but surprisingly, no SpaceX launches. We did have 6 launches from China, including the debut flight of the Changzheng 12A rocket from Zhuquan. The rocket is partially reusable and uses liquid methane as its fuel, similar to Landspace's Zhuku 3 rocket. The ascent portion of the flight went well, with both first and second stages performing as expected and with no issues being reported. The second stage reached orbit on the first attempt, but since it carried a dummy payload, nothing was deployed from this launch. At least, it did demonstrate that it should be able to deliver real payloads in the future, since it was able to go into orbit. Of course, the Changzheng 12A is meant to be reusable, so after stage separation, the first stage attempted to land back on Earth in one piece. The booster is fitted with grid fins, RCS thrusters, and landing legs to be able to do that, and even has strakes at the bottom to help guide the booster. While it seems like the first stage survived the initial entry, it looked quite scorchy and unfortunately failed its landing burn, eventually hitting the ground about 5 kilometers off from the landing pad. Just like Zhuku 3, the rocket launches from the inland site of Zhuquan, so there are no landing barges as there's no ocean close to the launch site. It just lands at a landing pad a few hundred kilometers downrange, or at least tries. It's quite interesting to compare the landing attempts from a commercial entity like Landspace and its Zhuku 3 rocket versus the Changzheng 12A built by the China Aerospace Science and Technology Corporation, which is a government entity. While Zhuku 3 seemed to survive re-entry unscathed, the Changzheng 12A was scorched and beaten up from it. Both also failed their landing attempts, but Zhuku 3 came within meters of the landing pad rather than 5 kilometers. This 2026 will see more attempts from each rocket to land their boosters, and other companies are also developing their own reusable rockets as well. So time will tell which one ends up becoming the first Chinese company or entity to successfully land a first stage. We also had another debut flight, the Hanbit Nano rocket, a launcher developed by South Korean company Innospace. The launch happened from the Alcantarilla launch center in Brazil. Yes, a South Korean rocket launching from Brazil. That's quite a unique combination. The rocket itself also uses a unique combination of propellants. Its first stage uses a hybrid propellant propulsion combining paraffin wax with liquid oxygen, while the second stage uses liquid methane and liquid oxygen as propellants. The rocket is also small, with a performance of only 90 kilograms to sun-synchronous orbit. Its debut flight, called Spaceward, was a demonstration mission to collect data on the rocket since it was its very first launch. While it cleared the pad, visual contact was lost not long after that, since there was a low cloud hanging above the launch site. The rocket appeared to fail around that time and fell back to the ground for an explosion, of which we just saw a glimpse of on the official broadcast before it was cut. According to the CEO, Innospace is now investigating the cause of the failure and using all the data from this flight to prepare for another launch in the first half of this year. Let's hope it flies farther than this first flight. Unfortunately, that was not the only launch failure we saw in the last 2 weeks. We also had an H3 rocket launching from Japan that didn't go to plan. The rocket had a successful liftoff and first stage flight, and the second stage reached orbit, but later than expected. The rocket was carrying the Michibiki 5 satellite, a Japanese navigation satellite that was bound for a geosynchronous transfer orbit. After orbital insertion, the second stage of the H3 rocket was meant to perform a second burn, but this was also cut short and left the second stage still in a low Earth orbit. This low orbit was far from the intended one, and it was in fact low enough the rocket eventually re-entered just an orbit later due to the drag of the thin atmosphere at that altitude. Following the launch failure, Mitsubishi, rocket manufacturer, started an investigation into the launch's failure. Preliminary data released in the last couple of weeks shows that there was a sudden drop in pressure inside the second stage liquid hydrogen tank right after fairing separation. Onboard footage also shows what might be the Michibiki 5 satellite falling off the second stage during its first burn to go into orbit. Really a front fell off kind of situation there. It's unclear what could have caused all of these events, mostly because the investigation is still underway, but it now means that any launches of the H3 rocket are essentially delayed indefinitely until this issue is fixed. This was H3's 7th launch overall and its 3rd of the year. It also was the second failure of the rocket since the failure of the second stage on its maiden flight back in March of 2023. It had been developed as an improved and cheaper rocket to succeed the older H2 family of rockets, but it clearly seems that there are still a couple of things that need fixing before it becomes a reliable launcher. Apart from those launches, we also had 2 Soyuz rockets launching from Russia, taking civil and military payloads into sun-synchronous orbit. India launched its launch vehicle Mark III as well, carrying AST SpaceMobile's first Bluebird Block 2 satellite into orbit. The company aims to launch more of these in the near future, with launches on New Glenn and Falcon 9 lined up for the first half of 2026. Rocket Lab also conducted its 21st launch of 2025 with an Electron launch from New Zealand dubbed the Wisdom God Guides, carrying the QPS-SAR-15 satellite into low Earth orbit. In this varied end of year, we even had a New Shepard suborbital flight carrying 6 more passengers to the edge of space and back. The flight is notable for having carried Michaela Benthaus and Hans Koningsman. Hans is known for having been at SpaceX for 2 decades, most of that time in the role of Vice President of Build and Flight Reliability. Michaela, or Michi, is also an aerospace engineer and works at the European Space Agency. However, in 2018, she had an accident and suffered a spinal cord injury that left her unable to walk. Ever since, she's been an advocate for opening up access to space to people with disabilities, participating in analog astronaut missions, and a zero-G flight with a group called Astro Access. Fun fact, she was on the second of those zero-G flights, and I was fortunate enough to be on the first. Michi is an awesome person, and I'm so happy she got to fly. So, Blue, when's my turn? Hit me up. Michi is friends with Hans, so he decided to go on with her and live the experience together. She went up to the capsule in her wheelchair and was helped on board by ground crews and Hans so she could get into her seat for the flight. The same occurred on the way out, with a much larger smile, of course, having gone through the experience of going on a rocket to space and coming back to talk about it. Now, depending on how one counts things, 2025 featured 324 launches with the intention of going into orbit. I say it carefully because there are discrepancies as to whether a launch failure from Iran back in September was intended to go into orbit or not. And there was also a separate pre-launch failure on the pad of a Chinese Kuaizhou 1A rocket at the start of March. Regardless, this was a really active year, and compared to 2024, we had over 60 additional launches. About 30 of those came from SpaceX, which went from 134 launches of Falcon rockets in 2024 to 165 in 2025. China also launched a lot more, going from 68 in 24 to 93 in 25. Last year also saw the debut flights of quite a lot of rockets, such as Blue Origin's New Glenn, which also gave us an impressive landing in November, Gilmour Space's Eris from Australia, Isar Aerospace with its Spectrum rocket from Norway. From China, we also had the Shangzheng 8A, Shangzheng 12A, and Zhuku 3 debuting in 2025 as well. With so many new rockets now up and running, plus the ever-increasing pace of SpaceX, 2026 may well become the first year that has more launches than days. Whether that'll happen or not, I guess we'll find out in a year. Next week, we may have a much calmer week than recent ones, with only 3 launches expected until our next report. All of them are Falcon 9 missions, with 2 of them being Starlink launches taking place from Florida Space Coast. The other Falcon 9 launch will be carrying the Cosmos SkyMed 3 satellite for the Italian Space Agency. The mission had originally been planned for before the end of 2025, but a ground systems issue forced it to delay a few days into 2026. Of course, those are all the launches that we think may happen in the next week based on the current information, but new launches may pop up unexpectedly between now and our next report. So as always, we recommend you go to nextspaceflight.com or download the app on your phone so you can keep track of spaceflight events at any time. And that's your weekly update of spaceflight news. I'm Sawyer Rosenstein for NSF, and Alicia will see you all again next week to recap This Week in Spaceflight.